Welcome to the part 2 of the video series of area of two-dimensional shapes, and in this video we are going to learn how to derive the formula of the area of a rhombus, a kite and a trapezium. So if you want to learn all about it, come on, let's nail it. Now, like I said, this is part 2 of the area of two-dimensional shapes, and if you haven't seen part 1 of it, just click on the link above and you'll be taken to the video straight away. So come on, let's have a look at a rhombus. Now, rhombus is a figure like this, and if you know, like a square, in a rhombus also, all sides are equal. But the only difference is that they are not inclined at 90 degrees like in a square, but all sides are equal, so we can mark them as equal. And let the side of the rhombus be S. And let me also draw a diagonal of the rhombus, like say like this, and let that diagonal be called D1. Now you know that a rhombus is also like a parallelogram, and because it is a parallelogram, the area of a parallelogram is base times height. So we can just say that the area of the rhombus also will be base times height, because it is exactly similar to a parallelogram, since the opposite sides are equal to each other and they are also parallel to each other. So it should just be base times height, and we can just take the base as any of the sides here, which is S, and then we'll have to drop a perpendicular. So just let's drop a perpendicular like this. That gives us the height of the rhombus, so we can just say that the area of the rhombus would be base times height. Now there's another way of finding the area of a rhombus, and that is, you can see that this is divided into two triangles. We can also find the individual area of each of the triangles and then add them together. So let's look at the triangle on top. Now we already have the base as D1, and let's drop a perpendicular also. Let that height be X. So if we look at the area of the triangle on top, which is triangle 1, let's call it triangle 1, that should be half times base times height. So half times base is D1 and height is X. So half times D1 times X. And now let's look at area of triangle 2, which is the triangle at the bottom. Here also we can take the base as D1 only, but we'll need a perpendicular. Let this be the perpendicular, and let's for the time being call that Y. So the area of this triangle would be half times base times height. Base is D1 and the height is Y. So it will be half D1 times Y. So the total area of the rhombus would thus be, we can add the area of the two triangles together. So half D1 times X plus half D1 times Y. And as you can see, we can take half D1 as common in both the terms, and taking them as common, we can just say it is X plus Y. Now if you look at the figure, what exactly is X plus Y? Well, X plus Y is nothing but the other diagonal of the rhombus, and let's call that diagonal 2. So we can just say that the area of a rhombus is also half times the product of the two diagonals, or half times diagonal 1 times diagonal 2. So let's write that also here, that the area of a rhombus is half times diagonal 1 times diagonal 2. Or you can say that, as we discussed earlier, because it's also a parallelogram, it is just base times height. Now I keep doing a lot of similar things on my channel, and if you're a student of mathematics or want to learn certain concepts about mathematics, you should consider subscribing to the channel, and just do so by clicking the subscribe button at the bottom of the video, and also do not forget to click on the notification bell, because that will make sure that you get each and every video to your email. Now, how about a figure like this, which is not exactly a rhombus also, it's not a triangle, it's not a parallelogram also. What is this? Well, this is a kite, and in a kite, you know that the adjacent sides are equal, or two pairs of adjacent sides are equal. So we can say that this side is equal to this and this side will be equal to this. Now here we can't apply the formula of base times height because it's not a parallelogram. Here compulsorily we'll have to divide it into two triangles and then find the area. So we can just draw again a diagonal, which is one of the diagonals, and let that diagonal be called D1. Now to find the area of the triangle on top, we'll need the height for that. So let's drop a perpendicular and let us call the height as say h1. So we can say that the area of the triangle on top, or area of triangle 1, will be half times d1 times h1. And similarly, to find the area of triangle 2, we need to drop a perpendicular from the opposite vertex. Let that be called h2. So the area of the triangle, this triangle, would be half times the base, which is d1, times the height, in which in this case is h2. So again, the area of this kite figure would be the sum of the two areas, which is half times d1 times h1 plus half times d1 times h2. So we can again take half d1 as common, and within brackets we can get h1 plus h2. Now like before, we can again look at h1 plus h2, which is the other diagonal of the kite. We can just call that d2. So we can say that the area of a kite is also half times d1 times d2, or just take the product of the two diagonals and divide it by half. What am I saying? No, sorry, divided by half actually becomes the multiplication by 2, and divided into half or divided by 2. Now let's have a look at a figure like this. Now this is a trapezium. In a trapezium we know that the one pair of sides are parallel to each other. Now this trapezium also has a base. So let this be called the base, which is B, and it also has a height. Height is the distance between the two parallel sides. So in this case, once drawn from the opposite vertex to the base, it will be this, and let us call that as H. Now to derive the formula of the area of a trapezium, let's divide it into two triangles. So let me draw a diagonal of the trapezium, say like this. Let me name the trapezium as A, B, C, D. So the area of the trapezium we can say would be area of the triangle at the bottom, the big triangle that you see, which is triangle ABC, plus the area of the other triangle, which is triangle ADC. Now the area of triangle ABC would be half times the base, which is B, times the height, which is H, plus the area of the second triangle. We need a base for that, so let me take this as the base. Let me call that A, so it will be half times A, and we need the height. Now height, you can drop a perpendicular from the opposite vertex, and as you see, the height is nothing but H. So we can say that the total area of the trapezium would be half times B times H plus half times A times H. We can take half and H as common, and within the brackets we'll just have A plus B. So we can say that the area of a trapezium would be half times the sum of the two parallel sides, which is A plus B, times the height. Now we are not looking at the area of only two-dimensional shapes, we are looking at the areas of three-dimensional shapes as well. And if you want to learn all about that, why don't you just click on the photograph here and get subscribed to the channel, because the next video is about that only. So please await the video, and meanwhile why don't you click on these videos appearing on the screen? Well, YouTube says they should be good for you. Have a look, enjoy them, let me know if they're good. As far as the area of two-dimensional shapes are concerned, I think you have nailed it. Take care. God bless.